Our solar system has been around for billions of years and might seem a bit monotonous. So, what if we altered the positions of our planets? What if Jupiter were placed right next to the Sun? Or what if Earth swapped places with Mars? Today, we'll rearrange the planets in our solar system from largest to smallest, and then reverse that order to go from smallest to largest. How would this impact Earth, and could we find a new home? This is What If. And here's what would happen if the planets change positions. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. First, let's see what happens if the planets are lined up from largest to smallest, starting with the Sun. This setup has a major issue, but before we discuss that, let's look at how the planets would line up. Jupiter is the giant of the solar system, with more than twice the mass of all other planets combined. It would move from its current position to Mercury's spot. Less than 1/10 of its original distance from the Sun sounds crazy? Well, astronomers studying exoplanets have found that large gaseous planets often orbit very close to their stars and are called hot Jupiters. In Mercury's orbit, Jupiter's orbit around the Sun would shrink from 12 years to just 90 days. Its average temperature would rise to about 167 degrees Celsius, causing its gaseous atmosphere to expand. What about Jupiter's moons? The icy layers of Ganymede, Callisto, and Europa might sublimate, forming water vapor and exposing the oceans underneath. However, the intense heat from the Sun would soon evaporate the water. If there were any life in Europa's ocean, it might briefly thrive in the warmth only to quickly find it too hot to survive. Next, Saturn would take the second position, replacing Venus. It would warm up too, with its average temperature rising from -140 degrees Celsius to 55 degrees Celsius. Saturn's rings would disappear under the Sun's intense heat and radiation. The rocks in the rings might survive, but the ice particles would melt and the dust would be blown away by solar winds. However, the interaction between Saturn's magnetic fields and the Sun could create new patterns. Now we come to the Goldilocks zone. Unfortunately, Earth is no longer in this ideal spot. We'll check on our new home later. For now, the habitable zone is occupied by Uranus, the third largest planet. Normally, Uranus takes 84 years to orbit the Sun, but in this new position, it would take just one Earth year. Basking in the Sun's rays, Uranus might transform from a cold, barren planet to one with potential for habitability. For life to exist, we need liquid water, carbon-based molecules, and an energy source. With more heat from the Sun, Uranus's water ice could turn into liquid water. The planet's icy atmosphere contains methane and ammonia, providing carbon-based molecules. The increased energy from the Sun would also be available. However, despite these favorable conditions, Uranus's high atmospheric pressure and lack of a solid surface make it unlikely to become Earth 2.0. Perhaps Uranus's moons might be more suitable for life. Or maybe the planet's conditions will improve over billions of years, just as Earth did. But we don't have time for that. Let's move on to the other planets. In the fourth position, Neptune takes Mars's place. Moving much closer to the Sun would warm Neptune up from its current -200 degrees Celsius. Its orbit would shrink from 165 Earth years to just under 2 years. However, Neptune's notorious storms might become even more violent due to the increased heat and energy. Now, let's talk about the big problem. This new planetary order would be highly destabilizing. With 4 large planets in close orbits, they would exert enormous gravitational forces on each other, potentially disrupting the entire solar system. Even if this doesn't happen, something terrifying awaits us in this new arrangement. In this order, Earth would be the 5th planet from the Sun, positioned between Neptune and Venus. If Earth orbits too close to Neptune, we could become its 15th moon. This might actually be the best-case scenario. Being much further from the Sun, Earth would receive less energy, causing our surface water to freeze and wiping out all life, including humans. Only a few creatures near deep-sea hydrothermal vents might survive. Anyone want to be a snailfish? Following Earth would be Venus, Mars, and then Mercury. These planets would experience drastically lower temperatures, with Venus's sulfuric clouds condensing into acid rain, sulfuric acid ice, and carbon dioxide ice, not ideal for life. Mars and Mercury, with little to no atmospheres, would become cold ice boxes orbiting the sun. None of this sounds good. I prefer the current order of the planets, but what if we reversed it? What if we arranged the planets from smallest to largest, with the smallest one closest to the sun? In this case, Mercury would stay in the first position, just like today. So far, so good. Mars would be in the second position, heating up to an average temperature of 32 degrees Celsius, like a hot day on Earth. However, any surface water might evaporate, and carbon dioxide from the ice caps and soil would be released. Would this create a thicker atmosphere? Probably not, as the atmosphere would likely be stripped away by solar winds, making Mars no more habitable than before. Next, we reach the habitable zone. Would bringing Venus into the Goldilocks zone create ideal conditions for life? Unfortunately, no. Venus would cool down slightly, but not enough to sustain liquid water. Its carbon dioxide atmosphere creates an intense greenhouse effect, making it too hot for life. Even if a comet delivered water, it would evaporate quickly. So, no new life on Venus. Earth would be in the fourth position, receiving half as much sunlight as it does now. This would cause Earth to freeze, with only small pockets of life potentially surviving. Humans wouldn't make it. In fifth place, Neptune would be closer to the Sun, possibly deflecting some asteroids headed for Earth and creating a beautiful night sky. Saturn and Uranus would swap places, likely without much change. Jupiter would move to eighth place, 6 times farther from the Sun than before. Its year would lengthen from 12 Earth years to 165, and its atmosphere would remain largely the same. However, Jupiter's gravity would have a significant impact on meteors and asteroids, flinging them around the inner solar system and causing increased impacts on the planets. I'm glad the planets aren't arranged by size, whether big to small or small to big. Either way, it wouldn't be good for Earth. We'd freeze and die, ending life as we know it. How did our solar system end up in its current order? About 4.6 billion years ago, it started as a big blob of gas. Gravity caused some of this to collapse and form the Sun, with other bits coming together to form the planets. A dense rotating disk of gas and dust influenced the positions of the planets. The smaller rocky planets were pulled inward, while gas and ice condensed to form the larger outer planets. A second phase of transformation began 3.8 billion years ago, when the orbits of Jupiter and Saturn locked together, creating instability. To counter this, Jupiter moved inward, and Saturn, Uranus, and Neptune moved outward. After a few million years, their positions stabilized to what we see today. Regardless of how it happened, I'm just glad Earth ended up in the Goldilocks zone. Based on this hypothetical, no other planet would be as suitable for human life, even if they were in the right spot. Let's hope Earth stays right where it is for a long time. But what if Earth were suddenly hit by a massive volcano? Then staying in the Goldilocks zone might be the least of our worries. But that's a story for another. What if? The arrangement of planets in our solar system has profound implications for the dynamics, stability, and the very nature of our cosmic neighborhood. If the planets were to change positions, the consequences would be monumental, affecting everything from gravitational balances to climate conditions on Earth and other planets. Gravitational chaos. The gravitational interactions between the planets maintain a delicate balance that has kept our solar system stable for billions of years. If the planets were to change positions, this balance would be disrupted. The gravitational forces exerted by larger planets, such as Jupiter and Saturn, play a significant role in shaping the orbits of other celestial bodies. If Jupiter, with its immense mass, were to swap places with a smaller planet like Mercury, the increased gravitational pull in the inner solar system could lead to orbital instabilities. These instabilities might result in planets being ejected from the solar system or colliding with one another. The asteroid belt, situated between Mars and Jupiter, could also be affected, potentially sending a barrage of asteroids towards the inner planets, including Earth. This could lead to catastrophic impacts, altering the surface and atmosphere of any affected planet. Climatic and environmental changes. The positions of the planets relative to the Sun are critical in determining their climates. Earth, situated in the habitable zone, has conditions suitable for life due to its distance from the Sun. If Earth were to change places with Venus, for example, the intense heat and high levels of solar radiation would likely strip away our atmosphere, leading to a runaway greenhouse effect similar to what is observed on Venus. Conversely, if Earth swapped places with Mars, our planet would receive significantly less solar energy, plunging into a frigid, potentially uninhabitable state. Other planets would also experience drastic changes. Mars, currently a cold desert, might warm up if it moved closer to the Sun, possibly allowing liquid water to exist on its surface. The gas giants, if moved closer to the Sun, might lose their thick atmospheres, dramatically altering their compositions and appearances. The outermost planets, Uranus and Neptune, could see their atmospheres freeze if they were repositioned further from the Sun. Impact on the asteroid belt and Kuiper belt. The asteroid belt and the Kuiper belt are regions filled with rocky and icy bodies that are influenced by the gravitational pull of nearby planets. Changing the positions of the planets could destabilize these belts. For example, if a planet with a strong gravitational influence like Jupiter were to move closer to the asteroid belt, it could scatter asteroids throughout the solar system, increasing the likelihood of collisions with planets and moons. The Kuiper belt, home to many dwarf planets including Pluto, could also be disrupted. Changes in the positions of the outer planets would alter the gravitational dynamics of this distant region, potentially leading to the ejection of objects from the solar system or causing them to collide with each other or with other planets. Effects on moons and rings. Many planets have complex systems of moons and rings that are influenced by their gravitational pull. Changing the positions of the planets would alter these systems dramatically. Moons might be pulled away from their parent planets, captured by other planets, or even sent hurtling into space. The rings of Saturn, one of the most iconic features in our solar system, could be disrupted, potentially dispersing the material that forms them. The positions of the planets in our solar system are not arbitrary. They have evolved over billions of years to create the stable, life-supporting environment we know today. Changing these positions would have far-reaching and catastrophic consequences, affecting gravitational balances, climate conditions, and the overall stability of the solar system. Thank you for watching and see you next time.